So if you have any questions, please don't hesitate to ask and interact with Professor. This is a very good opportunity that on behalf of the farmers, that you can pass the message and the knowledge from the academic expertise into of local to enrich of local agriculture.
How about any questions we want to ask? Anything we have can want to share? So quiet. We have you see I made this for NOPF to hope you all have a happy Valentine's Day. Today is a Valentine's Day. So wish you all happy. And we have a Saturday, so we don't have to work. Nobody gave me any flowers. I didn't give anyone flowers either. So, and whatever people should do, give flowers to everyone and to see if share the love. Hope all you and your family all in love. So is there anyone want to share some? We had Miss Wang went to Africa. She gave a lot of trainings over there and collected a lot of questions. And we eventually will get an answer to discuss all these questions for later. When each time we will discuss one topic. That's all good questions. So that's very nice. And we found a lot of things we need to understand the whole thing about our fertilizer. If you no one want to say something, and I'm going to share some what I think is important for NOPF or any fertilizer for agriculture, for crop or for any plants. For a successful use any fertilizer, here we talk about the NOPF or any, especially NOPF is what do you want to categorize them? You want to tell them is fertilizer or food or something else. Sometimes it's easier. We based on the basic chemistry of for our NOPF is have a lot. They coming from naturally plants and animal material. After fermentation, digestion, degradation, all kinds of procedure, we break down all these huge fibers, proteins, fat, all this stuff into small molecules. Then in the end, we have water-soluble nutrients in this solution. These water-soluble nutrients, we need a water that's soluble to be able to use, easy to use on plants. If not water-soluble, some nutrients we still can use in the soil for plants, like conventional fertilizer, NPK. N is nitrogen, P is a phosphate, K is potassium. In almost all cases, nitrogen is water soluble. So if you apply conventional fertilizer when they containing N or nitrogen, they will be ready to be used by plants. If either you spray on the leaf or you putting them in the soil because they are water soluble. For the P and the K, a lot of cases, P and K are not water soluble. That means you cannot spray on the leaf. When you spray on the leaf, they are not ready. They are not available for plants to use. So you need to put them in the soil. Let soil microorganisms to work on this P and K, make them change to a water-soluble format. Then will be available for plants to use. So microorganisms in the soils acting when we feed microorganisms, feed any food or fertilizer into the soil, they have two functions. One is to feed these microorganisms, another is to feed the plants. When they are not water soluble, you cannot feed the plants until your microorganisms work on it. Microorganisms, they do take these nutrients from this conventional fertilizer or any other organic material as the food to build for their own reproduction, make their population larger. Byproduct, they didn't do it, they didn't mean to do it, but they did. What they did is during the feeding or work on this old organic or fertilizer, they make this fertilizer water soluble, make them available for plants to use. Also, even if we don't see the microorganisms, it's so tiny, the bacteria or fungi, even something large ones like an earthworm or something else in the soil, you still don't see them. But the population, the mass, is huge in the soil. After they feed all your nutrients, you put them in the soil, their population is so big, their lifespan is not very long. The turnover rate is very fast. So they actually, when a lot of bacteria, a lot of fungi die every day. And when they die, they become fertilizer for the plants. So you have two functions. One is they feed the food or fertilizer in the soil. Then they increase their population and they die. They become, it's themselves as a fertilizer for plants. And another function is, as we said, they make this all other stuff water soluble. So when you see how important the microorganisms in the soil, we need microorganisms. But if we don't make your soil good environment for them live, their population will be very low or none. Then your fertilizer or anything you put in the soil will be not available. Your soil become poor and poor every day. So we need to improve your soil all the time by adding, because the microorganisms, they need to eat. When they need to eat, the basic things we need to give them organic material and water and air. A lot of time we don't think air and water are important for soil as nutrients. Actually, they are most important, even more important than your fertilizer, like we do. We cannot don't have air any moment. We need oxygen all the time. And then second important, we need water. So microorganism is an organism. They need air and water all the time. How do you get more air in the soil? You can till. You can make your soil. You can till the soil all the time. My upper generations, when I was little, when I was learning agriculture farming, they told me every time your knife, your shovel into the soil, it's acting like give a soil a fertilizer. So each time you move the soil, make the soil either turn it around, upside down, put all the weeds on it underneath, and make you actually your soil becomes soft. The air can get in. So the roots, the plant's roots, they need air all the time. Microorganisms also need air. So that's why we need till or use something to make your soil soft. But some sustainable agriculture specialists say they don't like tilling. They like it, don't touch the soil. Let the soil do themselves. Make your soil more conservative. It have several things to consider. If you don't touch the soil, which means you need to have enough vegetation on the top. You can keep, like we have your front yard or backyard, your lawns, the grass land. We never till the land, the grass. But the soil, how do you still keep that soil? You keep cutting the grass all the time. And you have make sure you feed the grass. So the grass have enough vegetation to suppress or other weeds come out. Sometimes you even need to do some herbicides to prevent the weeds germinate. So this, if you don't do any tilling, you have to make sure your soil is covered by vegetation. And you have to prune or cut your vegetation all the time, make sure your vegetation not become the weeds. Your weeds is too high, then they compete. Air, light, water, all nutrients with your crop. So if you don't till, you have to make sure you don't let this naturally happened vegetation become competitor. Your crop is your target. If you don't have a lot of land, then you need a high, very, very intensive farming. You have time to till, work in the soil, make the soil soft. Then also same time you need to feed them. feed them organic material for the plants and microorganisms. So for the soil, for the NLPF, for what NLPF, that's what we talk about water soluble. So this is also the benefit compared to conventional fertilizer. NLPF, we don't have to apply into the soil. We can apply on the leaf. Actually, the major use of NLPF is to spray on the leaf, make a foliar application. This way, you don't have a problem in the soil. The soil, when you put a conventional fertilizer or put NLPF in the soil, you have the potential to lose 70% of your fertilizer. Lose 70%. How much you lose? You remember how much you put your NPK in the soil? You put a lot. How much they can use, plants? Maybe 30%. The couple of reasons. NPK, the nitrogen part, is water soluble, as we talk all the time. Second is volatile. They can evaporate from the solid phase to gas phase. So they don't need to pass the water phase, liquid phase. They actually from granule to evaporate to the air, they lost. So if you put NPK or nitrogen on the surface of the soil, the air can take your nitrogen right away. Not too much will go into the soil and all evaporates. How much nitrogen in the and in the air? We have about 70% air or nitrogen. So much nitrogen in the air plants cannot use. And if we apply the nitrogen on the surface of the soil, you contribute more nitrogen in the air. So if you apply soil fertilizer into the soil, you have to cover it. You have to open the soil, put the NPK in the soil to cover it. If you cover it, if you don't water them, you basically use the soil as a storage place. You keep the NPK in the soil, they stay there because if we don't have water, they are not water soluble. And P and K for N, even they are water soluble, but you don't have good water, they are still not in the water solution. So when you put NPK in the soil, the soil is dry. Right now you use the soil as a storage place. They are not a fertilizer. Until you give the soil water, then they will become available for plants. So anything you put in soil, the first thing you need to cover. Second, you need to give them water. Then plants can use them. And also, where you put the NPK, you put it on a trunk or put it in other place. We are talking about like these plants. This is a drop line. All the active roots is on the drop line here. So in this region, the roots terminals are active. If you put the fertilizer here, the plants can reach them. If you put the soil nutrients directly close to the trunk, this is not available, not too far from active roots. So this is also So we consider all this for the fertilizer. We have a lot of factors make its effectiveness of your fertilizer. Because we use NOPF measured as a foliar application, so we will discuss what kind of factors actually make your application more effective. By understanding all this, you don't have to get advice from me or get advice from anyone else. You can make a judgment when, how, what, how do you spray your NOPF on plants. You think you need to consider plant situation. You need to consider environmental situation. You need to look at the leaf. You need to look at all these factors. By understanding the whole ecosystem of your plant fertilizer system, then you can make a judgment. When is the best time to apply your foliar NOPF or any other fertilizer? Let's look at the leaf. Let's look at the plants part. Plants, they have the leaf, we have issues. We are talking about, we ask you, spray on the chart, spray on the back of the leaf, not on the top of the leaf. If you spray is not that way, you are not actually the best way, because we still have this. You see this leaf, the top, the mouth openings, the stomata is the opening on the underside, underneath of the leaf. So the opening is in the back of the leaf. If you spray on the top, then you also top, they have more surface of the leaf, more waxy. If you put anything on top of the leaf, very slippery, they may run away. In the back of the leaf, they have more hairs. So if you spray on the back, actually the hair can hold the droplets. They don't dry fast. The top is more shiny, and anything they drop, get on the top, they slide away. But if you use big spray, like you have 20 hectares, you cannot spray with hand. Then you have no choice. You just spray on the top. But if you can, you try to spray on the back. This is a single leaf structure issue. Also, the leaf age. The older leaves, they are structured physiologically not the best time to take your nutrients. So we try to spray and when they are younger leaves. So the young leaves are the best time to take the nutrients. Like we human, when we are little, we grow several inches a year. When my age, not grow any single millimeter, actually going down every several millimeters every year. So the older, the growth stage is when they're young. Same the leaves, the plants. That's why we try to keep saying, so you see the pamphlets I give to you for each crop, how do you use NOPF? A lot of time we apply the fertilizer in the early stage. Don't apply in the later stage. Because the early stage, they are do a lot of vegetation growth. They are young leaves, not the old leaves. Since we have to think. And also you say, well, in the plants, you see the third one, the nutrients mobility. When NPK, it's kind of in the plants, they inside, if this is the plants, they can move everywhere easily in the plants. So if we, that's why you can feed NPK in the soil, and the soil will take the NPK from roots, they transport to every corner of the plants. So NPK, you can spray on leaf, they can take it from leaf to transport to other place. Or you can put NPK in the soil and they take from bottom up to transport to every corner. But I'm not mean P and K, actually nitrogen. NPK, three components together is not good for spray because PK is not water soluble. Sometimes PK is water soluble. You have to pay more because you have to make different formation. So sometimes you can get liquid or solid, but it's a water soluble kind of mix fertilizer. They make everything water soluble. But in most cases, NPK, if you buy 40 pounds, buy 50 pounds, or maybe like 20 kilos, that time P and K a lot of time is not water soluble. Then NPK you have to put into the soil, and the soil you have to cover. For some other elements, they are not move too much inside the plants. For those elements, if you put in the soil, they will not be able to transport from roots to up. So sometimes your top leaf or top fruits or flowers will missing some nutrients because some of these elements are not ready to transport from roots to leaf to the terminal parts. So for those plants, these kind of elements or fertilizer, you have to spray onto the target if you can. Most cases we can't. We don't have the money, we don't have the labor to do all this. But these kind of elements normally are trace elements. Plants don't need that much. Even if you don't spray onto the flower or onto the fruits, you don't see too much impact. Not like the macronutrients. Macronutrients are NPK. If you miss or lack of NPK, the plants will be hard to get a high yield. Or people will say, well, 100 years ago or 200 years ago, my ancestors, we didn't have fertilizer. How did they do? That's the thing is in the past, in history, in all the time, the Earth's population is low. Even low yield, we still can feed the population. Not totally, not hungry anymore, but it's kind of not mean enough, but it's okay to feed the population. Right now, the Earth's population too high. If we still use the traditional non-fertilizer agriculture system, the yield will be not enough. For after you apply the fertilizer, your yield can increase like 40 to 60%. So you basically doubled your yield. Of course, not only fertilizer, they also buy genetic selection of the new variety, not necessarily DNA selection. Everything hybridization or selective selection. By selective pressure, you also can get much better variety. After your hybridization, like rice, your yield doubled. So beside all this variety, species, genetics modification, fertilizer is the number one contribution of the high yield. For in the tropical area, for Africa, if you have a good vegetation, which means you have enough water. If some places don't have enough water, then you don't have much vegetation on your plants, on your farm, then your soil don't have organic material. I just came back from Southwest US. I was there for 6 weeks. They are tropical. They're tropical. They're supposed to have much better sunlight, nutrients. The soil should be better. But unconscious. The soil, the huge land have nothing because they don't have water. When they don't have water, doesn't matter how much light you give to them, how much temperature you give to them, they cannot produce anything. So massive land are deserts. Only have tiny, no more than high 20 centimeters, some little plants. The bushes, some can reach 2 to 3 meters, but it's only like a monoculture. Not too many species can survive in the desert. They're too high, too hot. In the summertime, you can get over 40 degrees all the time. I was lucky and I went to there for 6 weeks. For 6 weeks and to escape the coldest weather in New York. We had like a 40 something years, we never had that cold. We had a minus degree F, I don't know how much minus degree C, maybe minus 20, 30 degrees C. The temperature, that was too cold. My backyard line, I still have maybe 30 centimeters high snow. The snow, one night was 40 to 50 centimeters snow. But we have enough water here. Even we have a colder weather, we have water here. So the vegetation is nice. For the desert area, if you don't have water, doesn't matter how much light you give to them, you don't have vegetation. Then your soil is very poor. Basically, they're all sand. No soil, it's only sand. Then your sand is a problem. You don't hold any water. You don't hold any nutrients. You don't have small animals, not like earthworm. Even don't see any insects. So this is a soil issue. Next, we see the impact on the fertilizer is environmental factors. The temperature is very important. Why we have been talking about we want to spray MOPF before 9 o'clock in the morning or after 4 o'clock in the afternoon. This is 9 o'clock or 4 o'clock is artificial. It's not necessary to apply to every corner of the world. If your air temperature during the daytime is only 25, then you can spray fertilizer anytime during the day. It's for this spray only early morning or late afternoon is specifically for the hot place like Africa or any tropical area, because your temperature is too high during the day. When the temperature is too high, when you spray onto the leaf, they dry immediately. After they dry immediately, what does that mean? You are NOPF, you just diluted 1 ml to a liter, 1,000 times dilution. But you spray, you immediately dry out, you become solid again. Then you have no water. If no water, it's not a water solution. If not in the water solution, the nutrients will be like powder on our face. They stay there. They don't move. And how do they can get into the stomach openings, the plant's openings? So plants cannot take if you are not in the water solution. We want the NOPF in the water solution, in the film, a tiny, tiny film for a while. Then the nutrients can migrate and move to the openings. If you can move back to the whole openings in the back of the leaf. For the high temperature, if you spray on the back of the leaf, also is reduce evaporation. They don't dry that fast. The top, they dry immediately. For the spray on the back, they stay there a little bit longer time. So this is the temperature understanding. We want to spray at the temperature under 25 degrees C. So if you feel hot, it is hot. If you don't feel hot, it's okay for the time you spray. So like when I was in the business trip in New York with a minus degree, over there it's every day it's 75 to 80 degrees F. It's like around 25 degrees C. Their winter time is around 25 degrees C. Is the best temperature you can get. Or you set your AC temperature in your office. So what time you spray is temperature related. How do you know should I spray before 9 or before 10 or before 8? Don't need to remember exactly the number of a clock. You remember the temperature. If you go out, if you're comfortable, it's okay. You spray even the 12 o'clock. If you go out, it's 40 degrees already in the 9 o'clock or 8 o'clock. You still don't spray. Ask you spray in the early morning, it's because not of the time, it's because of the temperature. So if we understand that, when your farmers ask you what time I spray, nobody carry your thermometer with you all the time. You can check your cell phone to see what's the temperature you have right now. Either way, for the older farmers, we didn't have a thermometer. We didn't have a cell phone. How do we know? If you're feeling, your face, your body, you can feel If you feel hot, if you feel hot, the plant is also feel hot. If you feel very comfortable, this is the time you can spray. So if you go outside, oh, I forgot what time I should spray, 9 or 9:30. Doctor said I spray 9, but I forgot it's 9:30. Okay, don't remember that. You just say, if you go out, it's very comfortable, which means not hot. If not hot, you can spray, because we try to avoid the evaporation. We don't want to be dry immediately. So this is how do you remember the time of spray. This is base scientific base. So you don't need to ask much anymore. You don't have to remember. You just say, okay. Relative humidity is the same thing. If the air is too dry, then your spraying droplets will dry very fast. So all this we want is to reduce the speed of the drying. So let the spray solution on your leaf stay longer. If your humidity is high, then if you spray, they make this water soluble film on the leaf stay there for a long time. When you have a lot of moisture in the air, actually, if they start drying out, the air moisture will go from low concentration to high concentration, and the water will go into your solution to supplement your NOPF solution on the leaf. So actually extend your spray solution. Like we take, if this is my medicine, it's like this 1 ml, or this is not 1 ml, but if it's 1 ml, I drink the solution, finish it. You finish it. If the air is dry, if you don't have any water, but if you have more water, you rinse, put more water, you rinse again, you drink again. So if you high humidity, when the nutrients moved into your leaf, actually outside of the humidity, water can get into your NOPF solution, kind of like adding more water. You like rinse your leaf again, make sure all the nutrients go to your leaf. So when is the highest humidity during the day? It's not a long time, not a hot time. So it's also in the early morning or late afternoon. Because air is not too hot, not too dry, so the humidity will be high relatively in the early morning. This is another reason why we need to spray in the early morning and late afternoon. So if we can feel, then you can make a guess to see it's dry or not dry. Compared to the temperature, the humidity is less important, because the humidity actually it's a function of temperature. The low humidity is coming from the high temperature. So the temperature is the key. So try to avoid a high temperature. Then you also get a high humidity. The light is same thing. The light is have issue is if the plants, the field, is too hot, the light is too strong. When you go outside, you didn't have sunglasses. What do? You will close your eyes, don't open them very wide, or sometimes you just close your eyes. Why? You avoid too strong light. The plants is as smart as you are. You are smart. When you get a strong light, you close your eyes. The plants do. When the light is too strong, their plants, the leaf openings, they are closed too. When they're too hot or light is too strong, the plants, they're so smart. The opening, they close. After they close, what do you get? When you close, you spray how the nutrients can get into the plants because they closed already. So this is why also we don't want to spray when the leaf openings are closed. We want to spray when the leaf openings are open. When they open, then when they feel comfortable. When they are comfortable, the temperature is comfortable. It's above 10, below 25. From 10 degrees C to 25, they are comfortable. They are open. Everything is so sweet, so relaxed. They are open. That time, you feed them nutrients. They take, because everything is open, they take the nutrients into the body and they can grow. So this is why we avoid strong light, low humidity, and high temperature. Why wind is important? Of course, wind is important. If you have strong wind, what do we get when we spray? When you spray here, the wind will blow it away. You spray, you got nothing. So you don't spray when the windy time. How do you know is when you have to spray sometime, and if it's not raining and not hot, you have some little wind, you still need to spray. When is the best time of the day? The wind speed is the lowest. Is early morning or late in the evening time. In very early morning, the wind is very calm down, not much wind. Relatively, not exactly. The wind speed is the lowest in the early morning. If not have big weather system, if a big weather system, the wind all night, then it's different story. For the normal situation, in the early morning, if this is a plant, or if this tree is like 30 meters high, very high trees, they have insects on top. You cannot get them. How do you do this? Have a lot of insects on top of canopy, and you even cannot reach the spray. You spray now, they can reach the 30 meters high thing. One thing you can do is do the fumigation. You can pump like a fire, smoke in the early morning, like 5 o'clock. You pump at the base of your trunk. That time you don't have wind. They actually have wind. You can move little bit wind, move up, not sideways. So you can move all the air come here and to the canopy, and then they stay there for a while. This is one for the tricky tip. If you cannot get this top, very high insects on top, you can use the fumigation to fumigate, to send the gas or fog, F-O-G, fog, like a fog in the air, and like a small cloud to move up, and it stay there in the canopy for a while. You can control the insects. So this is the environmental factors. We understand all this, you will understand why we need to spray that time. So this from plants, the side back of the point of the plants, we see why we spray in the back of the leaf. And here we understand why we spray in the early morning and afternoon. Also here, plant age, we know why we spray on the vegetative in the early or the middle time of the crop plant life cycle, not spray in the late season because all the leaves are too old. You cannot, you can spray, you just lose money. Why we need to lose money? So we spray in the early, when the leaves are young, and we spray during the early morning, early time, and we spray back to the leaf. This is all the base why we do this recommendation. This one is a kind of look overlap with the first two slides. So for the plants, we in the lifetime, in the before flowering, or if we flower like a cotton, like okra. The okra is the flower fruits. Flower fruits keep doing that job. Then you can still spray during the flower time. But some crops, the flower one time, they stop. Then the peak of when you see the flower, it's time to stop. So you can spray all the time from seedlings to flower, and then you stop. Like a corn, if you you see the male flower, you still can spray. You start to see the female flower, it's time. This is your last time to spray. You don't need to continue because it's all the leaves, they start to move your nutrients to your seeds. And the leaves are starting getting old. The opening are closed. Why they closed? The closed opening, it's not, they don't want the nutrients. It's they don't want to lose water. If we keep opening, they dry fast. They lose the water. So if we close the opening, close the stomata, and they reduce the speed of the water losing. So keep the water. And then when they close, they start to move all the nutrients from leaf, from stem to the seeds. So in the early time, you even can chewing corn's stem. Some corn stem made the stem actually sweet like a sugar cane. I did a lot. When I was a kid, we looking for the male corn. What does male corn mean? That plant, they have the top male flower. They don't have a female. They don't have an ear, corn ear. So the whole plant is only have males, no female part. Their plants, normally the stem are sweet. It's like a sugar cane. Anyone close to the corn field, you can try. You don't have to buy. When I was little, my home only planted sugar cane one time or a couple of years, then we stopped. But we kids, we have a substitute. We have another sorghum related plants. It's not a sugar cane, but it's like a sorghum. The sorghum is very short, but my sorghum is very tall, like 4 meters tall. And the whole plant, whole stem, all sweet. It's like actually taste is better than sugar cane. Another substitute is we go to the cornfield looking for the male corn, and we just take this male corn, we're chewing the male corn. That's all the male corn's stem are sweet. It's like sugar cane. So you don't have to pay, and it's got a male sugar cane all the time. Another factors are to spraying solution. The spraying solution is very important. For the NOPF, we are not inorganic chemicals, not like a conventional fertilizer. It have some like a salt, SOLT, the format in the solution, but mostly are free amino acids, single molecule amino acids, and trace elements. Because we did all the digestion from this big complicated fibers, sugars, sugar is fiber is sugar, proteins or fatty, and make them break it down into tiny single molecule of amino acids. So they are like we drink the soup, the vegetable soup. You can drink very diluted amino acids, or you can drink very concentrated. Sometimes we drink high concentrated orange juice or apple juice. Sometimes you add a lot of water in it. Doesn't matter how strong the orange juice or cranberry juice or apple juice, your digestive system will be not burned because they are natural. Our amino acids is a naturally happened solution. So it doesn't matter how high concentration will not lead a leaf burning. But all other fertilizers, NPK, if you high concentration, you will cook, you will burn the leaf, will be reduced, result a leaf burning. So for all this NPK or any other chemical spraying solution, you have to watch the concentration. Whatever concentration asks you on the label, you have to follow. You cannot say, oh, I sprayed it more. You spray high concentration, 19, you try, all the leaf will be gone. Even the soap solution, the dishwasher, one time I had give my neighbors recommendation. I said, well, you spray some dishwash solution, you can kill your insects on your tomato plants. He asked me, how do I control the aphids on the tomato? I said, oh, you spray some salt dishwasher solution. He did. He killed the plants. In the end, he came back to me and said, oh, I sprayed, I killed them. Then I said, oh, how do you spray? Oh, I just spray this soaping dishwasher. I said, and I cannot stop laughing. He graduated from agriculture university too. He should have common sense. Adding high concentration to the leaf, you will burn the leaf. You have to dilute it. If you don't dilute it, you burn the leaf. So any conventional fertilizer, you have to dilute it. For NOPF, you still dilute it. Dilution is not the key factor for the leaf burning because we don't result the leaf burning, but we considering the cost effectiveness. We don't want to spray highest concentration NOPF onto leaf, you lose money. We only spray the best concentration for the plants can use, and we spend the least amount of the money. So we found 1-to-1 leader ratio is a good concentration. You can add a little more. You want to put 2 ml to a liter or 3 ml to a liter. But why? You lose money. You can maximum put 2 ml. Will not. When the leaf is young, you should use a lower concentration. Even half. You put 0.5 ml to a liter. But you don't put more than plants can take. If you put a lot more, plants cannot take it. Okay, we have a lot to talk, but I make a note. But next time we continue. You guys all have a great weekend. Happy Valentine's Day.
Happy Valentine's Day, Professor, and also happy Valentine's Day, ladies and gentlemen. Hope you have enjoy your weekend. We're going to see you next Saturday. Still, if you have any questions, please keep the questions and you can interact with us. Next week, we're going to invite one of young scientists to present this. So if you have any questions, you can text in the box. I'm going to send it to Professor. So thank you very much for being with us. Uh, Once again, happy Valentine's Day with your beloved ones.
Love you all.
Thank you.
Thank
Bye-bye.
you. Thank you.
Bye-bye.
Bye.
Bye.
Thank you, Professor. Bye.
Bye-bye.